Good morning, dear students. Hope you are all doing good. So today, in the last class, we have learned with the divisibility test, isn't it? Do you remember that? Okay. So divisibility test. So that is so how the divisibility test logically it is done. Okay. So without doing the long division method, how it is logically identified that it is divisible by 2, it is divisible by 4. That logic I taught you in the last class. So today, according to that, based on that, we will do some the problems. That is exercise 3.5. Exercise 3.5. In this first main, they have asked which of the following statements are true. Which of the following statements are true? In that first one, if a number is divisible by 3, if a number is divisible by 3, it must be divisible by 9. They told you that if a number is divisible by 3, it must be divisible by 9. So, it is false. Why? Okay. So, because if a number is divisible by 3, that is for example, I took a number 6 which is divisible by 3. That is the same number is divisible by 9 also. So, is it divisible by 9? So, 6 is divisible by 3. So that gives the answer 2, but 9, that is 6 is not divisible by 9. Okay. So that's why, so it is a false statement. Okay. So if a number is divisible by 3, it will not be divisible by 9 always. Okay. So that is a false statement. So then go to the next one. If a number is divisible by 9, if a number, any number is divisible by 9, it must be divisible by 3. Okay. So yes, it is a fact. So if a number, I took a number 18, it is divided by 9, that gives the answer 2. So then it will be divided by 3 also. It will be so divided by 3 also, that gives the answer 6. Like this. So if a number is divisible by 9, so it must be divisible by 3 also. So next we will take the third one. A number is divisible by 18. A number is divisible by 18 if it is divisible by both 3 and 6. So it is a false statement. I gave an example like this. So one number is there, that is 12 I took. So this is divided by 3 also. So 12 is divided by 6 also. Okay. So number 12 is divided by 3 also and 6 also. But so 18. But so it will not be divided by 18. It will not be divided by 18. That's why this statement is false. A number is divisible by 18. So if it is divisible by both 3 and 6 is the false statement. So next is the fourth one. If a number is divisible by 9 and 10, if a number is divisible by 9 and 10 both, then it must be divisible by 90. I took example like this. So this is a true statement. So if the number is divisible by 9, that is 9 tens are 90, divides, then gives the answer 10. So 90 is divided by 10 and it gives the answer 9. 90 is divided by again 90, that gives the answer 1. So this is a true statement. If a number is divisible by 9 and 10, so then it must be divided by the 90 also. Okay. So
Go.
Let us continue the fifth problem of the first main. If two numbers are coprimes, so let you recall what is a coprime. Okay, so coprime means two numbers with one as a common factor. Two numbers with one as a common factor is called as a coprime. If two numbers are coprimes, at least one of them must be a prime. At least one of them must be a prime. So it is a false statement. Why? So because we know that coprime means two numbers with one as a common factor. We will take the two examples, 18 and 35. And we will write the factors of 18. So that is 1, 2, 3, 6, 9 and 18 are the factors of 18. And factors of 35 are 1, 5, 7 and 35. That is 1 35s are, 5 7s are, 7 5s are, 35 1s are. So these are the factors of 35. So when we see the common factor, only 1 is the common factor in these both, isn't it? So only 1 is the common factor. That's why, so it is a false statement. Okay, they have given that if two numbers are co-primes, so at least one should be the prime. 18 is also not a prime number, 35 is not a prime number. It has many factors, isn't it? So they are not the prime numbers. So but they are co-primes. Okay. So this is about this problem. So next is all numbers which are divisible by 4. All numbers which are divisible by 4 must also be divisible by 8. 4 ಇಂದ ಯಾವ್ದು ಡಿವೈಡ್ ಆಗುತ್ತೋ ಅದು 8 ಇಂದನೂ ಹಾಗೆ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. So now it is a false statement. For example, 4 divided by 4, that gives the answer 1. So but 4 cannot be divided by 8. It gives the decimal, isn't it? So it doesn't give any remainder 0. That's why all the numbers which are divisible by 4 will not be divisible by 8. Okay. So then we will go to the next one. All numbers which are divisible by 8 must also be divisible by 4. Okay. So this is a true statement. All numbers which are divisible by 8. For example, I took 16. 16 divided by 8. Okay, that gives 2 as an answer. So it is also divided by 4, isn't it? So one number I took that is divided by both 8 and 4. That's why this is a true statement. Okay. So next we will see, if a number exactly divides two numbers separately. If a number exactly divides the two numbers separately, so it must exactly divide their sum. So this is a true statement. I took example 8. Okay, so 8 as an example. So that is divided by 2. 8 divided by 2 gives us 4. 10 another number I took that divided by 2, so it gives us 5. If I sum up these two, 8 plus 10, the answer is 18. This 18 is also divided by this 2, isn't it? If two numbers separately, if it divides by the same number, so it gives the remainder 0. In the same way, if we add these two numbers which we took, so that the answer that is also divided by the same number, so that is the true statement. Okay. So ಯಾವ ನಂಬರ್ ಎರಡು ನಂಬರ್ ಸಪರೇಟ್ ಆಗಿ ತಗೊಳ್ಳಿ, ಅದನ್ನ ಒಂದು ನಂಬರ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ, ಆಮೇಲೆ ಅದು ಆಡ್ ಮಾಡಿದ್ರು ಆನ್ಸರ್ ಡಿವೈಡ್ ಆಗುತ್ತಾ 2 ಇಂದಾನೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಎಸ್, ಇಟ್ ವಿಲ್ ಬಿ, ಸೊ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್. ಓಕೆ. ಸೊ in a first main last problem, if a number exactly divides the sum of two number, if a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. So whatever we see the previous problem, that is exactly opposite statement is this. So this is a false statement. This is a false statement. Why? So because, so I took examples here. So if a number exactly divides the, so that is divides the sum of two numbers, it must exactly divide the two numbers separately. So I took 18. 18 divided by 2. 18 divided by 2, if we do, we will get 9, isn't it? We will get the answer 9 and remainder will be 0. So if I take the, okay, if I take the sum of 18, 11 plus 7 as the sum of 18, so this 11 cannot be divided by 2. This 7 cannot be divided by 2. If I separate the sum of this number, these so numbers which makes up the sum, so that will not be divided by 2. Okay. So one number ತಗೊಂಡಿದ್ದೀನಿ, 2 ಇಂದ ಡಿವೈಡ್ ಆಗುತ್ತೆ. ಅದನ್ನ ಬಿಡಿ ಮಾಡಿದಾಗ ಯಾವ ನಂಬರ್ಗಳನ್ನ ಆಡ್ ಮಾಡಿದ್ರೆ ಆ ನಂಬರ್ ಬರುತ್ತೋ ಆ ಸಮ್ ಅನ್ನ ತಗೊಂಡಾಗ ಅದರಿಂದ ನಾವು ಈ 2 ನ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಅದು ಹೋಗೋದಿಲ್ಲ. So that's why it is a false statement. So next main factor tree method. So finding out the prime factorization, so by the factor tree method. So here are two different factor trees for 60. There are two different factor tree we can write. So missing numbers we need to write. 60. So 60 comes in the table 6 tens are 60. 6 tens are 60. That's why 60 can be split into 6 and 10. 6 and 10. 6 again can be split up into 2 table. 2 3s are 6, isn't it? So 6 can again be split into 2 into 3. In the same way, 10 can be split into, okay, 10 can again be split into 5 they have given, 5 2s are 10, isn't it? So that's why 2 I need to write in this empty box. So next, another tree, factor tree, possibility to write the another factor tree for 60. So 60 can be split again, so like this, that is 32s are 60, isn't it? So 32s are 60, that's why 2 is here. So then 32 cannot be divided again, 2 ones are, that is the ultimate end. So then 30 can be divided again, can be split again into 10 3s are 30, 10 3s are 30. And 3 is the ultimate for this, so 1 3s are 3, that is the last. So then 10 can again be split into 5 2s are 10, 5 2s are 10. So this is how we should complete the empty boxes for the factor tree of 60. Okay, so next we will take the third problem. Which factors are not included in the prime factorization of a composite number? Which factors are not included in the prime factorization of a composite number? The answer is, so 1 and the number itself. 1 and the number itself. How is it possible? Okay, so we will take the previous example, that is 60. So when if I write the factor tree method, factor tree of the 60, 10 6 are 60, 5 2s are 10, 3 2s are 6. Okay, so ultimately I got, so this 5, so which have a factor of 1 and the number itself, and 2 as a factor of 1 and the number itself, 3 that is factors are 1 and the number itself. Okay, so that's why, so the factors, so 1 and the number itself are not included in the prime factorization of a composite number. Okay, did you got the answer? Okay, so next we will move on to fourth problem. Write the greatest 4-digit number, so and express it in terms of its prime factors. So we know that, so greatest 4-digit number is, so 9999. Greatest 4-digit number is 9999, isn't it? So if I take the, so that is if I do the factorization of this this number, so first I will take the table 3, because so 9 will not go with the even number 2. That's why 3 3s are 9, 3 3s are 9, 3 3s are 9, 3 3s are 9. Again I took 3 1s are 3, 3 1s are 3, 3 1s are 3, and 3 1s are 3. Then I should take 11, because it doesn't go with any other number. So 11 1s are 11. So if I had to take the next two numbers, so I need to put 0, because 11 cannot be divided, that is it will not divided by 1. That's why, so I need to put 0. Then I should take 11 1s are 11. So these are the factors, 3 into 3 into 11 into 101 are the factors of a number, so 9999. Okay, in the same way, next fifth problem is there. So write the smallest 5-digit number and express it in the form of its prime factor. So the smallest 5-digit number is 10,000. We know that. So I need to take 10,000. I go on doing the same, so prime factorization. Okay. So if I do this one, 2 5s are 10, 0 0 0, 2 2s are 5, 2 2s are 4, so 1 carry, so 2 5s are 10, like that you should do. So you will get the prime factors 2 into 2 into 2 into 2, 4 times 2, 5 into 5 into 5 into 5, 4 times 5. Okay, these are the prime factors of the number 10,000. Okay, this is the answer for the fifth question.
Go.
Let us move on to the sixth problem. Find all the prime factors of 1729. Find all the prime factors of 1729 and arrange them in ascending order Now state the relation, if any, between two consecutive prime factors. Okay, so 2 to 3 problems are involved in this. Okay, 2 to 3 so problems are involved. Find all the prime factors of 1729. First we will find out the prime factors. So for this number, so it doesn't go with 2, 3, 4, 5, 6 anything. So directly we should take 7. 7 2s are 14, 3 comes 32, 7 4s are 28, again 4, so 49, it becomes 7 7s are 49. So then it go with the 13 table, 13 19s are 247, then 19 ones are 19. So we got the factors 7, 13, 19. We got the prime factors 7, 13 and 19. So what is the relation they have asked? We have to arrange them in ascending order, that is smaller to bigger one, and then we should find out the relation between the consecutive number. Numbers in a relation name. What is the relation between each consecutive number? We need to find out. So the relation is, when I do 13 minus 7, I got 6 as an answer. Again when I do 19 minus 13, I got 6 as an answer. Isn't it? So the difference between the consecutive two consecutive number will be 6. Okay, so that is the relation between these prime factors. Okay, so this is the answer for 6th one. The next we will move on to the 7th problem. The product of 7th one is, the product of 3 consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. Okay, so they have given the product of 3 consecutive numbers. Okay, so 3 consecutive number I will take 2, 3, 4. They are the neighboring numbers, consecutive numbers 2, 3 and 4. I took, so you may take 3, 4, 5, 5, 6, 7, like that, any 3 consecutive number you can take. Okay, so product they have asked, that's why 2 3s are 6, 6 4s are 24. 6 4s are 24. So this when divided by 6, so I got the answer 4. So in the same way, so they have asked the product of 3 consecutive number is always divisible by 6. Yes, it gives the remainder 0. So we can check with the different numbers, different consecutive numbers. So that will be so that is so we can verify with the different numbers. So next is the 8th problem. The sum of 2 consecutive odd numbers. Here they have asked sum of 2 consecutive odd number. That's why I should take 2 odd numbers. Okay. So that is 3 and 5 are the odd numbers. That is consecutive. That is neighboring odd numbers. So that's why I took 3 and 5. You may take 5 and 7, or 9 and 11, or 11 and 13. Like that, 2 consecutive odd numbers should be taken. So and they should be added. The sum of 2 consecutive odd numbers should be taken. And the answer which comes, that should be divided by 4. So by giving the remainder 0. Yes. So it can be done with this example. So 2 consecutive odd numbers ತಗೊಂಡಿದ್ದೀನಿ 3 5 ಇಲ್ಲಿ 5 7 ಅನ್ನೋ ಎರಡು odd number ನ ತಗೊಂಡಿದ್ದೀನಿ. So 3 plus 5 8 ಬಂತು, 8 4 ಇಂದ ಡಿವೈಡ್ ಆಗ್ತಾ ಇದೆ, leaving the remainder 0, isn't it? So 2 ಆನ್ಸರ್ ಬಂದಿದೆ. ಅದೇ ತರ 5 plus 7 ಮಾಡಿದಾಗ 12, ಅದನ್ನು 4 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದಾಗ so 3 ಆನ್ಸರ್ ಬಂತು, ರಿಮೈಂಡರ್ 0 ಬರ್ತಾ ಇದೆ. So these are these I verified with 2 examples. Okay. So next I take 9th problem. In which of the following expressions prime factorization has been done? 4 statement ಕೊಟ್ಟಿದ್ದಾರೆ, 4 expressions ಕೊಟ್ಟಿದ್ದಾರೆ. So 24 is equal to 2 into 3 into 4, 56 is equal to 7 into 2 into 2 into 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. 70 equals 2 into 5 into 7 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. 54 equals 2 into 3 into 9 they have given. So we should check the factors. 24. So we should solve with the prime factorization method. Solve ಮಾಡಿದಾಗ so 2 into 2 into 2 into 3 ಬಂದಿದೆ, but they have given 2 into 3 into 4. That's why this is here prime factorization is not done with the first problem. Okay, so this is correct, but they have given the wrong, isn't it? ಸೊ second 56 ತಗೊಂಡ್ರೆ 2 into 2 into 2 into 7. They also gave, so 7 into 2 into 2 into 2, this is correct. Okay. So our statement correct ಇದೆ. 70 ತಗೊಂಡಾಗ 2 into 5 into 7 ಬಂದಿದೆ. Yes, it is also correct. So prime factorization complete ಆಗಿ ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ. ಸೊ ನೆಕ್ಸ್ಟ್ 54 ತಗೊಂಡ್ರೆ ಸೊ 2 into 3 into 3 into 3 ಬರಬೇಕು ಆನ್ಸರ್, ಬಟ್ ಅವರು 2 into 3 into 9 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅಲ್ಲಿ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಮಾಡಿಲ್ಲ. ಓಕೆ, ದಟ್ಸ್ ವೈ A and D, the prime factorization is not completely done. Okay, so this is how the problem is done. Okay.